Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Hello. I'm excited to discuss your study on using large language models for automated detection of data quality issues in tabular datasets. To start off, could you explain the main motivation behind using LLMs for this purpose?
Absolutely. The main motivation behind using large language models, LLMs, for automated detection of data quality issues in tabular datasets is their ability to understand and analyze data, much like a team of experienced humans. These models have been extensively trained on a vast range of internet content, including a diverse array of domain knowledge and examples of code reviews related to data quality issues. This extensive training enables LLMs to identify potential errors in human-readable datasets, such as CSV files, with a level of intuition that mimics human expertise. This makes them particularly well-suited for detecting data quality issues without the need for explicitly defined rules, making the process more efficient and effective.
That's fascinating. Leveraging the extensive training of LMS to mimic human expertise in identifying data quality issues certainly seems like a powerful approach. Could you elaborate on how the DataIssue objects are represented and utilized in the context of your method for calculating the Data Dirtiness Score?
The DataIssue objects are like detectives that find and describe different types of errors in the tabular dataset. Each DataIssue object represents a specific problem in the data, such as inconsistent formatting or incorrect splitting of data. These objects are essential for calculating the Data Dirtiness Score because they provide detailed information about the nature and location of the errors, along with the confidence level in identifying them. In the context of the method for calculating the Data Dirtiness Score, the DataIssue objects are utilized to quantify the expected proportion of cells in the dataset that contain errors. They are used to assign a confidence score to each identified issue and pinpoint the specific location of the error, such as a particular row or cell. By converting these identified issues into the correct format using Python objects, the DataIssue objects play a crucial role in automating the detection of data quality issues and ultimately calculating the Data Dirtiness Score.
The analogy of DataIssue objects being like detectives, pinpointing specific problems in the data, is very illustrative. It's impressive to see how these objects are utilized to assign confidence scores and pinpoint the location of errors, ultimately contributing to the calculation of the Data Dirtiness Score. Could you further explain how GPT-4 was employed in demonstrating the method and the significance of its performance in automating the initial phase of data error detection?
GPT-4 was employed in the demonstration by analyzing the table and its metadata step by step, mirroring human analysis. It then identified data issues line by line, similar to how a person would approach the task. This process was conducted without coding to maintain simplicity and broad applicability. The significance of GPT-4's performance in automating the initial phase of data error detection lies in its ability to interact directly with databases, akin to the code analysis capability in ChatGPT-4. This opens up a wider range of possibilities for detecting data errors. However, the challenge lies in automating this process to ensure that the model doesn't deviate from its intended path without sufficient guidance.
The step-by-step analysis conducted by GPT-4 to identify data issues without the need for explicit coding is truly remarkable. The parallel to human analysis and the ability to interact directly with databases certainly highlights the potential for automating the initial phase of data error detection. The challenge of maintaining the model's intended path without deviating is an important consideration in ensuring reliable and accurate performance. In the context of broader applications, could you discuss how this method could potentially reduce the time and effort required for data cleaning and its implications for various industries relying on large-scale data analysis?
Large language models, LLMs, can be like a helpful assistant who has a superpower of understanding and fixing mistakes in a big puzzle. Imagine you have a huge puzzle with lots of pieces, and sometimes it's hard to find where each piece fits. The LLM can help you find the pieces that don't fit well and even suggest where they should go. Now, in the real world, when companies have a lot of data to analyze, they need to make sure it's clean and accurate. This is like making sure all the pieces of a puzzle are in the right place. If there are mistakes in the data, it can take a long time for people to find and fix them. But using LLMs can save a lot of time and effort by automatically finding and highlighting those mistakes. This can be really helpful for industries like finance, healthcare, and technology, where they use a lot of data to make important decisions. It's like having a super-powered assistant that helps make sure the data they use is correct, like having a superhero for data cleaning.
The analogy of LMS as a superpowered assistant for data cleaning, akin to a superhero for ensuring data accuracy, is a compelling way to illustrate their potential impact. It truly highlights how these models can significantly reduce the time and effort required for identifying and rectifying data errors, particularly in industries like finance, healthcare, and technology where data accuracy is paramount for decision-making. In a broader sense, could you elaborate on the scalability of this method and how it might adapt to different types of tabular data sets or industry-specific requirements?
Using large language models, LLMs, for automated detection of data quality issues in tabular datasets is like using a super smart detective to find clues in a mystery. The LLMs are trained on a wide range of internet content, so they have a lot of knowledge about different topics, kind of like how a detective knows a lot about different types of crimes. This means they can adapt to different types of tabular datasets or industry-specific requirements. For example, if the dataset is about students and their grades, the LLMs can understand the typical things that might go wrong in that kind of data. But if the dataset is about sales and revenue for a company, the LLMs can also understand the specific issues that might come up in that kind of data. It's like the detective knowing different clues for different types of mysteries. Additionally, if there are specific rules or requirements for a certain industry, the LLMs can be trained or taught to pay attention to those specific rules. It's like the detective studying up on the specific laws and rules in a certain city before starting an investigation there. So overall, the method for using LLMs to detect data issues can scale and adapt to different types of datasets or industry-specific requirements because of their broad training and the ability to be customized to pay attention to specific rules or requirements.
The comparison of LMS to a versatile and adaptable detective, capable of understanding different types of datasets and industry-specific requirements, is a vivid recipe of their flexibility. The ability to adapt to specific rules or industry nuances, akin to a detective studying up on specific laws before an investigation, underscores the scalability and customization potential of this method. Given the adaptability of LMS, how do you foresee the integration of this method into existing data quality evaluation processes, especially in terms of collaboration with human data analysts or data quality teams?